A Cat 5e cable will have more twists per inch. Why? So I can limit more of the magnetic field. If I'm pushing 1,000 megabits per second, I'm sending it at a faster rate. If I'm sending it at a faster rate, I'm going to be increasing the velocity. Increasing the velocity, increasing the bandwidth, it's going to cause me to have a bigger magnetic field around that wire. So I give it more twists per inch. Wait a minute, Kyle, are you telling me that I can actually take a Cat 5 cable and just open it up and twist more cables and run 1 gigabits per second? Yeah, good luck. But yeah, you could do that. And it'll be fine. The pinouts are different on the 1 gigabits per second as well. So you gotta be careful of that. So when normally I would just hook the cables anywhere I want. And you think about this, if you have 4 cables, and 2 are transmit, and 2 are receive, you have to make sure that on the other side, they are the same. So whatever pin 1 is, and 2, and 3, and 6, because those really are the pins that you're going to be using, you have to make sure that whatever color this is on this side has to be the same color on this side. And that means you have a straight through cable. Now, the interesting thing about this is you're going to be using the same pairs. So if this is the blue pair and this is the green pair, you're going to be making sure that you're not altering the pairs. I mean, you're not going to have a cable on this side. You're not going to have blue and then blue. I'm messing up completely today. You're not going to have blue, then blue stripe, and then green, and green. Actually, we'll say green and brown. These are not going to be your transmit, and these are going to be your receive. You want your color pairs to be a pair, which means if you're going to be transmitting, you're going to want to be transmitting on a pair that has a certain amount of twists per inch. You don't want to have a pair of receiving or transmitting wire where one of those wires is green and one of them is a total different pair sitting somewhere else. So I want you to think about this. This is what I used to do. I used to do my colors in order. And let's actually get to our cable pinouts anyway, since that's where we're kind of going to. So look at the colors that we have. These are our standard cables. Notice that I told you 1, 2, 3, and 6 are what we're using. 1 and 2 for transmit. Receive is 3 and 6. Now you can use whatever standard that you want. You can use A or B. Here's A right here, and B's down here, which is in this direction. But if we look at the actual pairs, notice that this and this, even though they're different, we skipped a couple pins, they're the same cable. Now, this is what I used to do back in the day when I used to make my cables, because I didn't really understand about the standards or the twist per inch or the magnetic fields. So this is what I would do. I would actually go in alphabetical order. So I will say blue, then blue stripe. I'm just going to leave that as a stripe. And then I would say, what's after blue? We have green. No, we have brown. Brown, then brown stripe. And then I will go to green. then green stripe, then orange stripe. I didn't want to have to remember all this when I was back, back in the day. So I just made my own. 1, 2, 3, 4, blue, brown, green, and orange. And let's see what happens. 1, 2, 3, 4, 5, 6, 7, 8. So these two are good. This one, let's look at this. This one, 3 and 6 are not. Now, everything worked fine. I could have had problems, never really realized it. But this is how I used to hook up my cables when I used to create them. I used to do it all the time. Because I wasn't a cable guy. Now, this is nowhere near, I'm talking about back in the 90s, guys, when I used to make my own cables because it was fun and it was cool to actually create these. And whenever I needed a cable and didn't have one, I would create my own. So, this is not good. If you pay attention to your pinouts here. Not a good idea. Now, if I would have hooked up 1 gigabits per second and it used all the pairs, I want you to think about that. We're definitely going to have some communication problems. In fact, you probably won't get communication at all. Where this was okay. Well, let's think about that because maybe this was already doing its job, canceling out. Going down the brown wire and green wire as it was receiving, not that big of a deal. But remember, it might be receiving on this end, but on the other end, it's going to be doing what? It's going to be transmitting. Because if I'm receiving on this end, and on this end, guess what's happening over here? It's being transmitted to me in this direction. So whatever this is plugged in on the side is going to be transmitted. So these standards, they're for a reason. If you want to create your own standard, that's fine. Just remember that these were chosen for a reason. And the reason was because of the fact of their magnetic field, their twists per inch. But the main thing is, as long as you have the 2 pairs, or have a pair that's doing the transmitting and the receiving, you'll be good to go. I've always done it that way back in the 90s, always had communication. Except when you try to do this with the gig, it's not going to work. And it's not a good idea to do it the way I used to do it. It's actually a bad idea. If you want to get proper communication, not have any issues. So notice that these are a pair. And this is a pair. Sorry, I'm doing the wrong ones here. This and this is a pair. That orange and brown kind of look similar. Then I was like, well, I shouldn't be all the way down here. Okay, so these are what we call pinouts because as we plug these into our RJ45 jacks or our RJ45 plugs, the green wire is going to go to the pin 1. Pin 1 will always be on the left-hand side as the clip of the RJ45 plug or RJ45 end piece, which is plastic. The clip will always be facing down, and your pin 1 will always be to the left. Now, this concept is what we call a straight-through cable, right here. Because pin 1 is going to 1, 2 is going to 2, 3 is going to 3, 4, 5, 6, 7, and 8. And that's the way it's supposed to be. Now with this is what we call a crossover cable. The crossover cables are a necessity still today. So remember what I said about, obviously, you're going to have, if someone's transmitting on this side, they're going to be receiving on this side. Now this makes sense because if I actually take this down here, let's kind of, why don't we just bring up Now we want to kind of leave it up here. Why not just move it all down? That'd be easier. Let's shrink it, select it all, and move it down. Apparently it doesn't want to move. So if I have a network card sitting on this PC, and here's another PC, and I got these cables coming across. Now this will be my Cat 5, but let's say that for giggles, we just have this cable going, these 4 cables going across. Now on the one NIC card, I'm going to transmit out here. And I'm going to transmit out this one. Here I'm going to receive and receive. The way I like to explain this is like this. And let's do this a little bit better here. Let's make it a little bit bigger so we can have cables a little farther apart so I can actually write. This is going to be transmit, this is going to be transmit, this is going to be receive, this is going to be receive. And that's on this PC1 side. I like to think of communication as walkie-talkies. It's my button here. Here's my speaker. Here's my antenna. Now, the nice thing about walkie-talkies is you can talk via a distance. But I want you to think about this. Here's Bob. Here's Tim. Now, Bob needs to speak to Tim. So Bob pushes this button. When he pushes this button, what he's doing is he's transmitting on this signal. Now, remember, this signal here, whatever it is, it's just a channel, a frequency, but we call it a channel. Which means if I put this one on channel 1, it's going to be on a certain frequency, and I put this on channel 1 on a certain frequency, they will be able to communicate. But when Bob pushes his button, he's going to send data out onto this channel. Tim's going to receive that data. But when Tim goes to speak, Tim's going to send data down that channel and Bob will receive it. Now, I need you to understand this. When Bob is sending traffic or sending data down this channel, Bob can only send the data. If he wants to listen to anything coming to him, he has to release. So they can only communicate or receive at one time. Now, this is called the real name is called half duplex. But that's not really the lesson we're talking about here. The real lesson is if these two pushes the button at the same time and they start communicating, there's no way. It's going to come in, they're going to collide. And the problem with this is neither one is going to be able to hear or talk at all. I mean, they can talk, but they definitely won't be able to hear anything coming in. So that means we have to understand something. In order for Bob to communicate with Tim, Tim has to have his finger off this button. And when he's having his finger off the button, what mode is he in? He's in receive mode. That's what mode he's in. He's ready to receive the data or the transmission. When he's pushing this button, he is then transmitting. So in order for this, the only way for this communication to be successful is when Bob pushes this button, and while he is transmitting, Tim is receiving. Does that make sense? So while Bob is transmitting, Tim must be receiving. When Tim is transmitting, Bob must be receiving. This is very important to understand because it makes sense. If Bob decides to transmit while Tim is transmitting, how's that possible? It's not going to work. It's like pushing water outside on one side of the pipe, of a water pipe, and pushing it on the other side as well. So let's think about this. We have a faucet here. Water comes shooting out. Now, we tie this hose to it. This hose comes out. This hose comes out to this end. And water comes shooting out. Now, what happens if I decide to take another faucet and tie a hose to that and connect it to this? Well, you got two sides pushing the water out, but it's not coming out of anywhere. Does that kind of make sense? You're colliding the water. It has nowhere to go. It just, pressure builds up and it just sits there. That's it. Although we're not talking about pressure and don't care about pressure, the bottom line is it has nowhere to go. So if this PC sitting over here was set up like this as well, which it is, the same network card that's in this PC is set up the same way as PC2. That causes a problem. Because PC1, when it transmits, guess where it's going to be sending its data? It's going to be sending down this pin, this cable number 1. And PC, when he tries to transmit, cable number 1. And guess what happens? They collide. It's impossible for this communication to happen. PC1 or PC2 would have to have it set up like this.